experience, UK and international, in multidisciplinary practices. And Emma is a member of Anderson Acoustics, specialising in noise, vibrations, acoustics and air quality. A specialist in acoustics for education, settings and public buildings. She started it with a PhD in classroom acoustics more than 20 years ago and has continued with that specialism. She's an SEND governor, and she'll be speaking following Chris. Chris is going to introduce what is involved in a noise impact assessment, if one is required, for air source heat pumps. So I'll hand over to Chris.
Hello, everyone. My name is CJ from Noise Harvest. I'll just share my screen. There we go. Can everyone see that? Yep.
Yep.
So yes, we're an acoustic consultancy, which was started in 2020. We focus on architectural and environmental noise. We're based in Cheltenham, but we operate nationwide. So yes, prior to that, I was in large multidisciplinary consultancies, and then subsequently started up Noise Harvest. So what we're going to cover today is if you have an air source heat pump and you need to do a noise impact assessment, what requirements and the purposes of doing the assessment, how to actually understand the results, and what should be included in the report. So firstly, the requirements. Why do you get asked for it? Is it's usually to satisfy planning conditions and to ensure complaints are not made after the actual installation, so it doesn't actually introduce noise creep into the actual environment. The standard that you would use is BS Form 4.2, which is it goes into detail on how to actually rate the actual noise and everything, which we're going to cover a little bit on. This isn't a very this is just going to be a very whistle-stop tour of Form 4.2, because otherwise we could be here all night from doing this. So firstly, what we tend to do is we agree a scope of works with the environmental health officer, who's usually requested the assessment. The reason for this is they've asked for it. So if we agree it, they will know what's going to land on their desk in the report, and everything is going to be agreed, such as the noise survey, which establishes your background. So you'd go out and survey. Then you would find out what plant is being proposed, in this case air source heat pumps. Then you would actually analyze the plant and see if it needs any corrections, such as tonal corrections or impulsivity corrections. And then you would calculate the impact. That's a very, very quick way of doing it. So it's going to delve a little bit deeper into those. Firstly, why agree a scope of works? The EHO might actually have a different idea to you about what's required. So what we usually do is find out who the local authority is. After a little bit of to and fro-in, we get to speak to them. This can take a couple of days. We will then agree which is the nearest noise sensitive receptor. By this, I'm talking about the nearest house or to the actual air source heat pump, that can be up for debate sometimes, and EHOs might have a different idea or might have prior knowledge about which one it is. The duration of the survey as well. They may want to see a survey longer than what you would think or shorter than what you would think. And it may take account of weekends if your air source heat pump's covering a weekend. This is all down to the EHO. And on top of that, the modeling software that you use, if you're going to model it rather than hand calc it, you need to agree that the relevant bit of software is going to be acceptable. Right, so BS 142, the requirements for the survey. First of all, your sound level meter. When you're doing a survey, you would need to use a class 1 sound level meter. So when you read a report from a noise impact assessment, make sure that you're using a sound level meter that's also in calibration as well as class 1. Look at the location of where they surveyed, because you want to be at the nearest noise sensitive receptor or as close to the noise sensitive receptor you can be. Sometimes it isn't practical to be in 1 meter from the facade of someone's house. They tend to get upset. So you take a representative location where the noise levels will be the same. Meteorological conditions. You need to survey in certain conditions. You can't have it raining, and you cannot have wind over 5 meters a second, which is equivalent to 11.2 miles an hour, to be totally exact. And then the duration of the survey needs to be long enough to cover, to actually have the relevant times in it. So for day, you're looking at 1 hour durations, 1 hour increments. So you'd need to do more than one hour for the survey. Ideally, no less than 3 hours, but better if it's a 24-hour survey for that, because then you can actually work out what your typical L90 is for daytime, which is done over 1 hour, and then for night times it's 15 minutes. So you would break that down into 15-minute increments, and then you would work out your typical L90. So I'm pretty sure I'm preaching to converted here that everyone knows that a dB isn't a dB, and it has lots of different descriptors. So your background is your L90. So from there, you would go out and do your survey. You would go and collect your sound level meter, and I hope it hasn't been vandalized. And if it has, you can cry. So the noise survey, we just discovered, ideally 24 hours, not in rain or high winds. The results need to be averaged over 1 hour for daytime and 15 minutes for nighttime. So you'd actually calculate that via using a histogram to find out which is your typical background. Then from there, you would speak to yourselves, find out the location of the plant. You'd find out the plant, the information of the plant, the actual data from it. Ideally, you'd want to be using sound power for this, which is LW. Some manufacturers only have sound pressure data. For this, you would need to have a distance of where it is measured, and ideally the conditions it was measured, because it can vary greatly if it was measured 1 meter away in a really reverberant room compared to 10 meters away outside in a free field condition. So once you've established all of that, you look at your plant and you'll see if it actually needs any corrections adding to it. So these are kind of like penalties that you'd actually add to the plant. So you would have tonality, impulsivity, intermittency, and other things like that. The aim of this is to get the plant with the assessment to be below or equal to the typical background. If it goes up to 5 dB up above the actual rating, you will start to notice a difference. And if it's 10 dB up, it's definitely going to be a difference. So once you've figured everything out, the report must include the following. So your statement of who you are, the qualifications, the source being assessed, subjective impressions from the actual survey, the measurement locations, measurement information, weather conditions, date and time, intervals, background levels, rating levels, conclusions, and most of all, really importantly, uncertainty as well. So without those, you will kind of run into problems with the EHO if those aren't included. So yes, when you look through a report, make sure you've got those. Make sure you look at see if the sound level meter's actually in calibration as well, and look at the locations of where they surveyed it as well. So what we've actually covered is a very whistle-stop tour of the requirements for an assessment, how to very, very quickly interpret the results, and what's included in the report. Right, there you go. That's it from me. I hope you enjoyed that.
We'll go straight to the questions at the end, if you don't mind.
Yeah,
So
that's fine.
We'll have Emma's talk next, and then we'll have.
Yeah.
If you can put your hands up at the end for questions, I can't see the chat. If you want to put the questions, put them in the Q&A, please. Thanks, Chris.
Over to you, Emma.
Okay, thanks. Can everyone see my screen? Hopefully you can. I'm going to start with an apology. I've been on site all day in a school in Heathrow, and okay, all right. And as I expected, I'm in a public library, and I've been asked to move, and I'm going to have to move into a rather noisy cafe now. So you might have to bear with me for about 90 seconds. Sorry about that.
Anybody got any questions for Chris while Emma moves? I've got one. I've seen 10 dB as a limit that some people have quoted in specs recently. Is that too high?
Is this the 10 dB below the background?
No, above, I think it was. Or it should be.
Right.
I think
so if you're,
I might be remembering wrong. It might have been 10 degrees below.
Yeah, I was going to say it's usually 10 dB below. That is to prevent any noise creep as well. So that's really, really. So that is usually a local authority requirement that they put in to make sure that nothing actually goes wrong, and you never get this thing called noise creep.
But you were saying 5 dB above is
yeah,
sort of
it starts to become noticeable. You usually wouldn't accept that, but you can you can start to use that, but you wouldn't use, you'd usually work to equal or below the background.
Okay.
And
So
then
equal or below, and then some people
yeah.
require 10 dB below.
Yeah, some people require 10 dB
So
below the
bang
background
it up.
or 5 dB below the background.
So it's quite important we find that out early on, I think. As we come
Yes, yeah. This is another reason why you contact the EHO and speak to the EHO.
So it's not a planning requirement, it's an EHO requirement, is it?
Well, local authority requirement, and
Yeah.
without that you wouldn't
Yes,
get your
it's-
planning.
Okay. Are you back,
I'm
Emma?
in a much noisier place, so I don't know if this is
We can
Okay.
still hear you.
practical for your audience.
No, it's fine at the moment. We can't hear any background at
Is
the
it?
moment. Let's go for it. Yeah.
Do chip in, so because I can't bear it if it's not going to be
No,
very
I
easy
think because
to hear,
of your
so I'm just-
microphone is probably quite good. It's quite close. So
Okay, I'm going to rattle through this. This goes, but shout if it becomes a problem. So this presentation was something that I presented at Education Estates last month, and it's really all about kind of trying to design beyond the building bulletins. It'll have a lot of stuff that, as engineers, I've tried to make it as non-technical as possible, but as engineers, you'll probably appreciate the technical side of things too. But it's kind of thinking outside the realms of building services and ways and going to kind of a whole design for schools, really, every different aspect of the building regulation. So here we go. So if a presentation by an acoustics consultant has ever made you feel a little bit like this, please don't fear, because at Anderson Acoustics, our mission is to try and make those sorts of complex topics understandable for everyone. So that's including things like navigating the different performance standards and making sure the advice is clear, and going for quite pragmatic solutions, because there's always a bit of a balance, isn't there, between the building services design and getting the noise levels right and quiet enough, but not always as quiet as possible, as you'll see in this presentation. So my background, I'm a director at Anderson Acoustics. I have been working in classroom and schools acoustics for a long time. I think my real strength these days is the amount of work I've done on troubleshooting projects. So when schools have been completed, but the school still has sort of interesting acoustic problems, I tend to be the one that gets called in. I've done that on behalf of DFE, local authorities, and various other clients as well. And my role as a school governor with a specialism for SEND means that I do have a good awareness of acoustic issues in live working schools and maybe live working leisure centres, like I find myself in right now at the moment. Okay, so the acoustic design watch list, what we're going to run through is what's actually missing from the building bulletins. Does it matter? Of course, and most of them I've highlighted because it does, and how we improve that situation. And then lastly, I have a few slides on what is the future for beyond building bulletins. So the one on acoustics, number 93, it's now 21 years old. The last time it had a major update was 10 years ago. So now we're in the current state of the fact that BB93 really is outdated, and it certainly isn't universally inclusive. As building services engineers, you're probably interested in all of the sound transmission paths, which are highlighted in black here, so noise emissions, and that's what CIBSE has been talking about, and then room side noise as well to the building itself. But the whole acoustic design needs to look at transmission through the building fabric, that's in the red lines, transmission from room to room, so called internal sound insulation, that's the blue arrows, and then room acoustics design in the green arrows shown there. I won't dwell on this too much, but this is quite a nice visual analogy of speech perception. So in the first diagram on the left, you've got a perfectly received anechoic transmission message, no echo, silent conditions, not like the environment I'm having to tackle here, and perfect transmission of the message. When you have a longer reverberation time, that's actually acting to blur the gaps between the sounds. Each different sound has gaps between it of each word, and it's those glimpses of silence between the sounds, which is where we get to understand those words. So that's reverberation time acting on blurring the speech signal. High ambient noise masks the speech signal so that we have less so-called signal to noise ratio. We need to get the sound signal high enough above the noise signal in order to get enough intelligibility out of that. And then when you have both acting together, you've got that compound detrimental effect. It's worse than the individual reverberation and noise acting individually, it becomes worse than those two individual factors. So in terms of the scope of the building bulletin for things like noise, so starting with indoor ambient noise levels, really that's focused around speech between student and teacher, and it's assuming a quiet classroom, very much under control of the teacher, quiet and ready to learn. So what's actually missing from that? There's a number of things. One is outdoor activity noise. We usually tend to design for environmental sources like road traffic, like aircraft, rail. But I mean, this is a bit of an amusing image here, but it is always things like lawnmower noise, which the school will actually complain about if you've designed a nice natural ventilation strategy with open windows, and other outdoor activities like play, noise, like sports noise, that sort of thing. Music breakout noise, again, via openable windows, can be an issue into things like courtyards and other outdoor teaching environments. Then we've got masking noise. So we don't always want to go for the absolute quietest noise levels, background noise levels all the time. Sometimes a certain level of noise is really important for things like speech privacy, particularly in offices, which I'll come to later. And then you've got just the noise climate in outdoor learning spaces, thinking about the soundscape, thinking about the job that things like green infrastructure and the job that can do to actually shape our soundscape and make the outdoor learning environment better. And then you've got noise impact from things like Mugas and other sports pitches. So we use the same, well, a similar sort of assessment to the one CJ was talking about for plant, but it is a little bit different and different guidance documents when you're actually talking about noise from playgrounds and Mugas. And then we've got airborne sound insulation. So what's missing from that? Again, that focuses on between spaces and a little bit of a mention of sound transmitted from circulation into teaching spaces. The standard for amplified sound and music is not great and could probably be improved. But again, mentioning speech privacy, that becomes really important when safeguarding is an issue for things like offices. Here's another example of airborne sound and when speech privacy can be an issue. I visited this school last week. It's been open for about a year. It's a really great design. The head teacher's office, though, is on the right-hand side, just probably in front of the lady with the pushchair there. And the head teacher is very paranoid because they've got a passive natural ventilation strategy. It is attenuated, but it's quite a moderate performance for the office there. And she's quite paranoid that people gathering outside her office can hear the safeguarded conversation. So it's just having to think in the round a little bit about those sorts of issues rather than just ticking the boxes within the building bulletins for compliance. Another issue is when spaces get repurposed. So this is an example of one that we got called in to do troubleshooting on, and it was an archive room, and very quickly archive rooms which don't have any designated teaching or office space can sometimes very quickly become used as offices, and the sound insulation has not been thought about because we're all on a very tight budget, and it's not designated as a teaching space. It quickly falls out of the scope of acoustics and sound insulation. So as soon as that gets repurposed with speech privacy issue, and the person that was in this archive room working as an admin space right between the head teacher and deputy head's offices, and could hear all the safeguarding conversations which were taking place. So maybe it's about thinking about a minimum performance standard so that we protect and future-proof against whether those spaces change. And then we've got impact sounds, another type of sound insulation. Mainly footsteps noise is what the building bulletin focuses on, as in people, walking across the floor at a walking pace. What's missing, therefore, is as soon as you have a high activity space situated above a noise-sensitive classroom and you have significant impact sound, rarely is there the budget to engineer the floor to get that footsteps high impact sound insulation performance standard up to scratch. And there are so many examples, and there's still examples today of first floor sports halls, and it is a big problem. And then lastly, reverberation. So again, the building bulletin scope is mainly thinking about one-on-one communication here, assuming that the rest of the students in the space are quiet, ready for learning, listening to their teacher. And therefore, it's just making sure that the teacher's speech isn't too blurred, and it can reach the student at the back of the room, basically. There are some other standards on music teaching, but won't go into those too much. What's missing then is this concept of universal acoustic design, making sure that we're designing for every children with every need in the classroom to the extent that we're able to. And that means when we're working in groups or we've got quite a build-up of occupancy noise, making sure there's enough absorption in that classroom to deal with that mode of learning, rather than just assuming we have to wait for the class to be absolutely quiet before those children can access the speech that their teacher or their peers are making in the classroom. And then the other issue is psychological safety. That's become quite a big buzzword. Lots of schools are talking about it, talking about designing for psychological safety, but also all of the resources and all of the displays, signposting, scaffolding that they can do to make sure that the space feels safe for any child. And as we see, there's some children who are more vulnerable to those effects of not feeling safe in the space. And if they're not feeling safe in the space, they're not safe in the space, they're not ready to learn. So in order to tackle this, we can't just think about the acoustic design in isolation. We need a joined up approach, and that means thinking about the technologies that are available within the classroom, and also sensible classroom management techniques. So what are the needs of the children who may be more vulnerable to noise, and how do we need to consider them? So there's some definition under BB93, but as I mentioned, 21 years old now. This list of needs, you've got hearing impairment, speech, language and communication needs, ADHD and autism, auditory processing disorder and visual impairment. So that's what's defined. It's probably now more widely coined this term oral diversity, if you've heard that, but I think that's sort of coined in the last couple of years, and how we're now widening that listening need a little bit more. Because schools need to anticipate the needs of deaf and other disabled children. It's not okay for a school to just say, we don't have any deaf children in this school at the moment. It's about their potential for them to be future users of the space as well. So since BB93, we've got a couple of extra needs that have come to light. One is social, emotional and mental health needs. And that's the needs which is probably most vulnerable to the effects of psychological safety. And we've got dyslexia, which is in reality, it's probably other underlying language needs or disorders. But if you take a sample of children with dyslexia, they're more likely to have a worse speech perception performance than children without dyslexia. And then the other two is under the Equality Act, there's a couple of protected characteristics. One of those is age discrimination, and one of those is English as an additional language. So they both need to be considered. They're not a type of special educational need, but they do need considering under the Equality Act. We've done a lot of research at Anderson Acoustics. We've done a little bit of work for the DFE as well, and we're taking that learning forwards hopefully into new criteria, which are going to be developed, which I'll tell you a little bit more about. This graph might seem a bit complicated, but what we've looked at is, on the one hand, the actual listening disadvantage that happens for each type of need. And as you can see, if you have a profound hearing impairment, that's by far the greatest disadvantage. But equally, if you have something like ASD and you are in a noisy classroom, you will still be disadvantaged to some extent. That needs to be balanced by the actual how many children in a classroom are likely to be disadvantaged, to that extent. And that's shown in these pink bars here, whereas hearing profound is sort of down at 0.1%, which means about one child per school. Speech, language and communication needs is nearly up at 10%. And in fact, mild hearing loss is up at about 15% there. And it differs between which sector you're looking at. And we've got all the data for nurseries, primaries, secondaries, etc. So what we can actually do with that data, firstly, it's important to note that designing inclusively doesn't just mean designing for deaf children. Universal acoustic design benefits absolutely everyone in the classroom, and those with certain listening needs more than others. And what we can do with that data is evaluate the impact of better acoustics for every individual school in the country, and that means we can prioritise any investment in acoustic design nationally. And in fact, that's what we're doing for a large noise insulation scheme, trying to figure out about 40 schools affected. Where do we target the money for better noise insulation? Language, the extent of different types of learning need, and then come up with a sort of prioritisation list to start with the most vulnerable schools first. So it's been quite a useful exercise. Just touch on age as a disadvantage here, as I previously mentioned. So in early years, there's a good evidence base, which shows that we need to think about good acoustics, most of all in early year settings. They are the loudest, usually about 85 decibels on average. They've got the highest need of speech, language and communication needs, the highest need of mild hearing impairment. Children, very young children in those settings have very limited focus skills. Also, that's things like auditory processing and phonological awareness. And sorry, I looked like I was, hopefully you can still hear me because it looked like I was cutting out for a second there. Also, you can see that the early years are the most disadvantaged by age. So they're a very vulnerable group, but acoustic standards are fairly unregulated in most settings. Unless a nursery is part of a school, there aren't any statutory acoustic requirements to achieve. There are opportunities for the early years sector. There's quite a bit of government funding floating around, and there's plans to create up to 3,000 new nurseries, and that's in empty primary classrooms at the moment. So I think given that there is some opportunity for capital funding there, it is time to set out some sensible acoustic performance standards for early years. So back to universal acoustic design. It's important that we take a bit of a reasonably adjusted approach, and this is the whole approach that underpins special educational needs. You look at what reasonable adjustments you can make to minimise disadvantage. So that applies to acoustics and listening disadvantage as well. It's important to control occupancy noise, to make sure things like reading performance, SATs performance, and just to make sure you're not, you haven't got noise levels that will trigger behaviours in autistic pupils, like repetitive behaviours and that sort of thing. And that can really get triggered when the sound level gets too high. So it's important to control occupancy noise, but at the same time, we've got to balance that with providing enough support for teachers' voice. Thinking about natural ventilation, so that's where the CIBSE engineers will come in a little bit more, and bearing in mind this is mainstream, not specialist school provision. Here's an infographic here which sort of tries to show all the different things that we can be looking at here. So that we've got assistive devices, which I've got a couple of slides on. We've got classroom management, as I mentioned, and we've got this combination of reasonably adjusted acoustics. And there's a couple of criteria here. It's a shorter reverberation time, and it's a reasonably low noise level. And that in combination with good assistive technology would probably suit most of the needs for most of the listeners in the classroom. So personal listening aids are not just for those with severe, profound hearing impairments. There are studies that have shown that they are really useful for students with mild hearing impairment, ADHD, social, emotional and mental health, speech, language and communication needs, auditory processing disorder, you name it. There are some very beneficial stories. At the moment in practice, that's quite difficult because at the moment these sorts of assistive devices are only handed out to those with significant hearing impairment. It's an NHS thing rather than a joined up thing between Department for Education and NHS. This is another summary slide really on how we can sort of eradicate the disadvantage. So I've mentioned listening aids, I've mentioned acoustic design. There's a whole list of classroom management strategies, which is important to just remind schools, teachers of, most who will be using these sorts of strategies quite naturally, but sometimes then maybe needs to be a bit of a reminder. On the other side here, we've got provision of things like pods or good classroom furniture, so you can have a bit of an escape space when the activity noise builds up too much within the classroom to suit children with some needs. And this is an example of a classroom noise app. It's called Too Noisy. It costs £3.50. You stick it on your whiteboard and the whole class manages their own noise level. And it's a really good way of actively managing noise levels. So psychological safety, sort of jump back to that a little bit, but the spaces I'm talking about when we're worried about design for psychological space is things like dining and canteen rooms, assembly halls and sports halls as well. We also need to think about designing for speech privacy to make sure those confidential conversations stay safeguarded and confidential. And the rest is about focusing on activity and transition spaces. This is that school again, Notting Hill and Ealing School, where we've got well acoustically controlled transition spaces through sound absorption on the walls and on the ceiling as well. This is that larger space too, and that's been really positively received. We've done quite a lot of follow-up surveys with the students who were in the previous building, which wasn't very well acoustically treated, and they're very pleased. It's the first thing they mentioned actually was good acoustic designing there. And the sixth formers have come across and they choose to spend their time in this study space because of the acoustics being so successful. That's their hall as well, which has been flexibly and well acoustically treated, which means that they can really increase the multi-purpose nature of that space. So steps towards eradicating that acoustic disadvantage. First, we need to assess the needs in any student cohort, and it will be different for each school. And we've got the DfE census data where we can figure out what is needed for each individual school. We need to think about those design solutions being universal and applying those principles in all classrooms. Then it's about balancing the factors, because what we want to make sure is that the teacher's voice is balanced. If we put in too much absorption, the teacher's voice won't be very well supported towards the back of the class, and that's particularly important in a large mainstream classroom. We need to think about other constraints like natural ventilation, and then management-wise, we can use things like noise management apps and listening aids as well. Lastly, we need to think about creating safe spaces, and that goes beyond just classrooms. Here's a summary of the watch list. I won't repeat myself because this might be being recorded, so you should be able to probably share the slides afterwards. So where are we headed? Just a couple of slides to finish up. An update of the building bulletin, the 93 number one, anyway, it seems quite unlikely for now. What is changing is the Department for Education is bringing out a new output specification in the new year. And there's also the DfE are working on their new designs. So the intention with those is to bring in create a more inclusive mainstream. And so we hope to see those reasonably adjusted acoustic performance standards finding their way through into the output spec. Obviously, for the output spec only covers a fraction of the stock of refurbished and new build buildings, but local authorities do tend to pick up on the output spec, for example. So we're expecting to see those standards feature in some form of employers' requirements documentation, even if it's not the building bulletin. This is the new model designs and their scope. They've got three main areas: health and well-being, nature, and standardization. And acoustics does have a thread throughout all of these themes. Natural ventilation hopefully is obvious to everyone in CIBSE, and the need to balance natural ventilation with noise ingress. these three are all about psychological safety, because we've got better circulation, better dining, better social spaces, and with that comes good acoustic conditions in those spaces too. With access to nature and a focus on natural materials indoors, yes, our acoustic finishes can certainly be better. They can better accommodate natural materials, and we're already finding solutions have been engineered in that direction. In terms of access to nature, I mentioned green infrastructure and the needs to think about soundscapes outdoors and noise in outdoor learning spaces as well. We're seeing that more and more often as a condition of planning, actually. And any sort of covered dining and outdoor teaching spaces, we should be thinking about where that sits in the landscape rather than it ending up right next to a road, which sometimes, unfortunately, it does. And just in terms of standardization, that creates an opportunity to think about acoustic planning, checking on a minimum standard to make sure if you do repurpose the spaces, we've still got a baseline good standard of sound insulation and not too much cost, and that we're thinking about things like speech privacy as well. So I'll just leave you with this, get back to Notting Hill and Ealing, which was a good case study and seems to encapsulate all of those aspects of the new model designs, things like natural materials, natural acoustic panels. Acoustic pinboard was really important here. We had natural ventilation, which was a good achievement on a noisy site that's affected by aircraft noise, and a view out to nature as well. I hope you could understand that. That's probably the most difficult acoustic conditions I've ever had to speak in. I hope it managed to make sense for you.
Really nice. We didn't really notice the background much, so you did very well.
It's just me battling with it then.
I could see you were battling a bit. It shows the demands on it comes through noisy background, isn't it, in a school sort of thing to deal with that sort of noise. Yeah. Has anyone got any questions for either Chris or Emma? We've got a few minutes, 15 minutes left if we want to ask a few questions. I've got one on concrete floors. Any comments about concrete floors? What do you have to watch out for?
You're on mute, Emma.
Thank you. Sorry. Concrete floors are useful because they provide quite a lot of mass, but you're going to need to put some sort of covering in to deal with footsteps noise. People don't like floating concrete floors too much now. So, once you start asking for a high performance floor, that can be an issue. And that's why it's really not a good idea to put your sports hall up on the first floor. The underside of the soffit, though, obviously is very reflective. So you need to start introducing absorption in a different way. Obviously, over the last 10 years or so, rafts have been very popular, but they don't perform as well at low frequency. So your space might still sound boomy. And I think that's something we need to balance out as we move into talking about acoustics for universal design. Is that what you were getting at, Richard, or have I missed something?
I was wondering if you say you have to put a covering on a concrete floor. What if you want a concrete floor as the finish?
Then you definitely need to float it. It would need to be a concrete screed that gets floated, because footsteps noise, and I know because I've had to measure in lots, which, when you get too canny with the scope of things like building bulletins and you've value engineered everything out, someone somewhere along the line has said, oh, aha, Building Bulletin 93 doesn't really apply to offices under building control. So that all gets value engineered out. And of course, who are the people that will be the first to let you know if things have failed? It's the head teacher and all the senior leadership team. So you need to get their spaces right. If you have footsteps noise over a concrete floor and those people are trying to work in the spaces below, they will find it impossible very, very quickly. So yeah, you'll have to make the structure work harder if you're trying to work with a concrete finish. And just footsteps noise within the classroom. Actually, that's another thing that should be on the watch list. It's not mentioned in BB93 because they always imagined you'd have carpeted floors or vinyl, which is a bit cushioned. But the build-up of footsteps noise within the classroom can be problematic if we don't treat that finish.
So how would you get over that, Emma? Is there any way of...
Well, as I say, I think you couldn't do much about it if you have a concrete finish. You probably have to ask, you know, that if you were in somewhere like Denmark, they tell the children to take their shoes off and
The slippers, yeah.
Yeah.
In Denmark and Finland, Sweden, they do have slippers. Yeah. Okay, thanks. So any questions? Have we got anything in the Q&A? Because unfortunately people are muted. So if you put questions in the Q&A, sorry, I haven't been looking, but we don't appear to have any yet. Anything anyone wants to put? No, it doesn't seem so.
I can see one here from Paul.
Oh, okay.
Fisher. What are the challenges and solutions when refurbing older inner city schools? Okay, that's a good question. I think one of the big ones is that you end up with a lot of lightweight structures, and it can be very difficult to just achieve enough mass from those. They do tend to be noisier, although you can probably do a lot with maybe changing around some of the orientations if you've got the luxury of being able to relocate off those noisiest facades, or put some of the slightly less noise sensitive spaces. Some practical spaces can sometimes cope with being nearer the noisier facades, since you've got your sort of core English and maths perhaps towards the rear of the building. But yes, lightweight can be a big issue, but really there's no reason why you can't get the reverberation time right, and that's probably one of the most critical issues. I guess it depends. Sometimes in refurbs, you've got limited scope to actually upgrade things like the glazing, but I guess equally important actually is the indoor ambient noise level. And you've got things like sirens, you know, going past on main roads. It's the maximum noise levels that can be just as disruptive as well as the average noise levels. So where you can, I would say go for upgraded glazing and a sensible system for ventilation and overheating as well. Otherwise, you'll upgrade the glazing and you'll still have to open those windows in order to get any air into the building too. So it's possibly a higher level of refurbishment you need in inner city spaces to get that right.
I think there's a role for hybrid vent solutions where you've got high noise levels outside.
Yeah, I mean, hybrid ventilators are good, you know, when they're sort of individual, they serve individual classrooms. I think that can be a good solution, and you can get attenuated systems, so they can cope with pretty high noise levels actually, provided that you are able to fit an attenuator in between the units that's wall mounted and the grill, and that's a more common solution. And I think we certainly do have to be thinking about that bit of a negotiation between the noise limit that you end up with and something that's actually a hybrid and therefore sustainable solution. We only want to put in mechanical supply and extract where we really have to, because the noise levels are, you know, very, very high, because you don't want to end up with high operating costs for the school. It is important to strike that balance, and we can strike that balance for the most of the time.
Anything else? Oh, there's some new posts. Hang on. Neil Blacklaw. What issues, you can see these, can you, Emma? What issues arise from noise in passive house led cascade type ventilation MVHR systems?
Is that, do you mean where you've kind of got a you've got a sort of central ventilation spine, I'm guessing, and then you've kind of got passive house where it's sort of drawing in? Well, I'm
not sure what the cascade bit refers to, but MVHR is when you've got mechanical heat recovery units in the classrooms.
Yeah, maybe you mean cascade where it's not sort of one unit per classroom. So that's
maybe a centralized system, maybe, yeah.
Yeah, so if it's a centralized system and you're branching off to various different spaces, maybe from one large MVHR unit, crosstalk and the effects of that on sound insulation is really key you need to make sure you've got attenuators between the different branches to maintain the sound insulation performance.
So Neil's asking about air into the classroom and extract through the, say, atrium or dining area. So
yeah, okay.
yeah,
So there is a sound insulation performance to be achieved via that room front. That is, it's possible to overcome that with a sort of attenuator in the room front there, and there are BB93 standards to do which you, like a tick box minimum performance standard. Where that might become difficult in practice is if you've got an activity space outside the classroom, so you've got higher noise build-up than would typically happen in just a circulation space, during lesson time where the noise is quite low. So that's where you might want to have a higher attenuated performance. But it's definitely possible to achieve the BB93 standards with an attenuated system going from the classroom out through that room front.
And sometimes I've seen the atrium have they extract through to the atrium via restore.
Say that again, Richard.
Some people extract via restore, so it's from the classroom to the straw and then to the atrium, which gives you a room to acoustic.
Okay, so using a lobby.
Attenuated a bit.
Using a lobby, yes, that's true. Yeah, we've seen that. It's quite a useful way of doing things. So CJ might have some ideas on that as well.
Hello. Yeah. What was that? Sorry.
Where you're trying to attenuate a passive house system.
Yeah.
And you've got air into the classrooms and extract through an atrium or a dining space. What sort of measures to put in to attenuate the noise?
Yeah. Oh, yeah, definitely crosstalks.
Crosstalk attenuators.
Yeah, that would be my main go-to. And actually, there's always the management of the actual timetable to not allow the actual dining room to be used when there's classrooms in use there, so you can timetable it. That'd be an easier way to do it as well.
There's ventilation implications as well. I'm pretty sure Neil will be aware of those as well. Say fumes from design technology being extracted through the atrium, I've come across as a problem. So, you've got the return air path through the atrium, but if you've got fume sources in the
interestingly,
practical spaces.
Wasn't a passive house system, but just going back to, just going to find that image for you, where we had a passive attenuated. So these were attenuated louvers behind this hit and miss brick facade, which worked once they got working. They did work okay, but I think one or two of the louvers were missed by the contractor, and very quickly this became a favourite roosting space for pigeons. So one thing we didn't embark on was noise from pigeons outside, literally settling on these bricks, going through the acoustic loops. So it's another one of those sort of just trying to be aware of the acoustic issues. That
also I've seen this same problem can have problems with summertime ventilation, because that ventilation may not be enough for summertime cooling. So the one particular one I know had quite big natural vents like this, but they did have to put in portable air conditioning for summertime use, because the most critical vent flow is during summer when you need to get rid of the heat. So if that happened to be south facing, that elevation, you got a huge area of glass. It could have problems with overheating,
They have got those large openings.
So they open as well, do they? The windows?
Yeah.
So
one's a large opening, one is a attenuated louver. That's the idea, where they need to have those large openings.
And cross vent, I suppose. So does it have cross vent, or must have? I think. I wouldn't have thought single-sided vent would be adequate. I think it would have to be a cross.
They've got cross vent in this one as well.
Yeah, might
And actually, the school have reported that's not so much an issue, even though they've got those transitional sort of breakout spaces, which are, you know, a bit more actively used than your average corridor, but they say that works very well. So I guess the attenuation levels are sufficient enough, and we only just use the BB93 ones for those as a minimum standard.
Yeah, so that's an example of passive architectural design, I guess. Is that Ealing, you said? Ealing and...
That's right, Notting Hill and Ealing. Yeah.
See if there's any more. I think we've reached the end of the questions. So thanks very much, Emma and Chris. I think it's been really useful.
Thank you. Apologies again for my setting.
Congratulations for dealing with it. You've overcome that one. That was brilliant. Yes. Thanks. All right then. See you.
Thank
Bye
you.
now.
Okay. Bye-bye. Thank you.
Bye all.